villains of the universe, swallowing all that comes their way, allowing nothing to escape. So for astronomers, the center of a black hole is the ultimate unknown. No information can escape from within a black hole's gravitational stronghold. There is no way to find out what is in there. Not even light can escape. So how do we know that they are even there?
Black holes themselves cannot be observed directly. However, astronomers can see the indirect effect of black holes because the one thing they do possess in abundance is gravity. Hubble's high resolution has revealed the dramatic distorting effects of black holes on their surroundings. And not just gravity. Astronomers find that when material is packed tightly enough around a black hole, it can ring like a bell. This is the actual note produced by a black hole some 250 million light-years from Earth. It reverberates through the disk and has been altered here to fall within the range of human hearing. In reality, it's B-flat, some 57 octaves below middle C. Astronomers believe that black holes are singularities, simple points in space, no volume, no extension, but infinitely dense. Black holes can be created during the final collapse of a massive star many times the size of the Sun. The stellar corpse left after the demise and collapse of a massive star can be so heavy that no force in nature can prevent it crumpling under its own weight into an infinitely small volume. Although matter has apparently disappeared, having been compacted into nothingness, it still exerts a powerful gravitational pull, and any stars or other objects that come too close can be pulled in.
For any black hole, there is a point of no return called the event horizon. Once something, a nearby star, say, is pulled in past this point, it will never be seen again. On its way towards the event horizon, the doomed star will begin to follow a fatal spiraling orbit. As the star approaches the black hole still further, the matter closest to the hole feels a greater attraction than the rest of the star, sucking and stretching the star out towards the hole, until the immense tidal forces pull it to pieces and devour it. There are quirkier aspects to these objects too. A twisting of space and time that warps and slows even the passage of time. All objects with a mass deform the very fabric of space and time, but black holes do this to an extreme degree. According to Einstein's famous theory of general relativity, an intrepid traveler who could visit a black hole and hang above the event horizon without being swallowed would eventually return to find himself younger than the people he had left behind. Perhaps the most curious objects astronomers have hypothesized about are wormholes. A wormhole is essentially a short cut through space-time from one point in the universe to another point in the universe. Maybe wormholes, if they exist, will someday allow travel between regions in space faster than it would take light to make the journey through normal space.
Hubble has shown that black holes are most likely to be present at the centre of all galaxies. There's one at the centre of our Milky Way, a giant, supermassive black hole, perhaps 1 million times bigger than those produced by the collapse of a single massive star. It could be the result of a merger of many stellar-sized black holes formed during the remote history of our galaxy.
When two galaxies collide, the black holes at each of their centers will perform an elaborate dance. Long after the two galaxies have merged into one, their central black holes continue to orbit each other for hundreds of millions of years before their final violent merger into a single weighty black hole. This final process is so powerful that it changes the fabric of space-time enough that we may be able to observe it from the Earth with a new breed of gravitational wave telescopes or from special spacecraft in orbit. However, compared with the millions of years it takes for galaxies to merge, the final cataclysm at the cores would be relatively brief, so the odds of seeing such an event are small.
Until as recently as 50 years ago, astronomers thought the universe was a mostly peaceful place, but this is far from the truth. Space is often shaken by violent events. Cataclysmic explosions of supernovae, collisions of whole galaxies, and the tremendous outpourings of energy resulting from matter crashing into black holes. It was the discovery of quasars that gave us the first glimpse of this turmoil. To ground-based telescopes, quasars look like normal stars, and that's exactly what astronomers first thought they were, naming them quasi-stellar objects. But quasars are in fact much brighter and further away than stars. They can shine more brightly than 1,000 normal galaxies, and are powered by supermassive black holes.
Stars that orbit too close are pulled apart, draining into the quasar-like water into an enormous cosmic sink. The spiraling gas forms a thick disk heated to a high temperature by its free-fall motion towards the black hole. The gas blasts its energy into space above and below the disk in colossal jets.
Quasars are found in a wide range of galaxies, many of which are violently colliding. There may be a variety of mechanisms for igniting quasars. Collisions between pairs of galaxies could trigger the birth of quasars, but Hubble has shown that even apparently normal, undisturbed galaxies harbour quasars. But quasars are not the only high-energy objects astronomers have found. A serendipitous discovery is something you make whilst looking for something else. Such events have often changed the course of astronomy. Gamma-ray bursts were discovered serendipitously in the late 1960s by US military satellites on the lookout for Soviet nuclear tests. Instead of finding the most devastating detonations produced by humans, some of the most powerful blasts in the entire universe were spotted.
These astoundingly energetic blasts of gamma rays are detected at least once per day from random directions in the sky. Although gamma ray bursts last only a few seconds, the energy they release is equal to the amount of energy radiated by our whole Milky Way over a couple of centuries. Gamma rays are not visible to the human eye, and special instrumentation is needed to detect them. For 30 years, no one knew what caused these bursts. It was like seeing the gamma ray bullet fly by Earth without ever glimpsing the weapon that fired it. Together with nearly all other telescopes in the world, Hubble looked for the smoking gun for many years. It observed the positions in the sky where gamma-ray explosions had been seen, trying to find any object at that location. But all efforts were in vain, until... In 1999, Hubble observations were fundamental in determining that these monstrous outbursts take place in far distant galaxies. The cause could be the blast produced in the final cataclysmic collapse of a massive star, or the dramatic encounter of two very dense objects such as two black holes, or a black hole and a neutron star. Black holes are certainly some of the most exotic objects in the universe. As well as affecting matter, they can also show up in some other spectacular ways, because their enormous gravitational fields can also deflect light. In fact, rays of light that pass close to a black hole will not follow straight lines, but will be bent into new paths, creating a natural telescope that can peer further into space than ever thought possible.